Hello everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode weekly contest 385 and we're going to discuss all of the 4 problems that we have. More importantly, we're not going to discuss the first problem, we're just going to discuss the hard version of that particular problem, that is count prefix and suffix pairs 2. The solution for the easier problem would be exactly the same. So let us just start with the problems. I'm just going to open them in a new tab. And this is the second problem, which was a medium level problem, and it said that we have been given two different arrays with positive integers, and a prefix of a positive integer is formed by one or more digits, right? So prefix is basically, you can consider, let's say this is one integer, right? So the prefix will be 1, and then another prefix will be 10, third prefix will be 100. So basically one or more digits starting from the left. This is what a prefix is. Now we had to find, let me just read this again, a common prefix. They have defined what is a common prefix. So they have taken two integers a and b and an integer c. So c should be a prefix of both a and b. For example, if we consider these two numbers, what is the prefix of these two numbers? That is going to be 5655. Why? Because 5655 is present in both of them, right? So we just have to find the length of the longest common prefix among all pairs of x and y, such that x is from the first array and y is from the second array. So basically, you can take any one number from here, from the first array, and you can take any one number from the second array, and you have to count, or you have to find the number, find the maximum value of longest common prefix, right? So how can we actually solve this problem? You can see that the values itself are from 1 to 10 raised power 8. So what are going to be the number of digits in each number? That are going to be 8 digits at max, right? Or if it is 10 raised power 8, it is going to be 9 digits including the 1, right? So there will be 8 zeros and 1 1. This is the worst case when we will have a total of 9 digits, right? And how many values do we have? 5 into 10 raised power 4. So 5 into 10 raised power 4. How many prefix, how many unique prefix can we form? Those are going to be 5 into 10 raised power 4 into 9. So that is 45 into 10 raised power 4. This is the maximum number of unique prefixes that we can form using any one of the arrays, right? So this is within a reasonable range, because this is, let's take it roughly to be 10 raised power 5, or if you want to take more approximation, let us take it to be 10 raised power 6. So that means we can make 10 raised power 6 at most unique values if we consider all the prefixes of any one of the arrays. So let's say we try to make all the prefixes from the second array. Now we will have 10 raised power 6 unique values. Similarly, we can make 10 raised power 6 prefixes from the first array and just check whether this prefix is present in the second array or not. If it is present in the second array, that means I have found a common prefix, and my answer is going to be maximum of answer comma prefix length, right? So let me just demonstrate this part again, what I just said. What I'm saying is, consider the second array, calculate all the prefixes that you can from the second array. How can we calculate the prefixes? For example, the first digit is 10, the second digit is 123, the third digit is, let's say, 1. So the first prefix from the first array is going to be 1, the second prefix is going to be 10. From the second position, from here, 1 is already present, so I don't need to count it again. 1 2 will be a new prefix, and 1 2 3 will be a new prefix as well. Similarly, from the third element, 1 is already present, I've already considered it, so I don't need to consider it again. So these are the 4 prefixes that I can form from the second array. And in the worst case, in the worst case, we are going to have 10 raised power 6 such prefixes. Similarly, we can calculate all the prefixes from the first array, and for each prefix from the first array, we can try to search that particular prefix in the second prefixes list. So this, let's say this is a list or a vector or a set, whatever you want. This is stored in some data structure which supports efficient searching in logarithmic time. So let's say log n is the searching time, right? This can be supported by a set, or this can be supported by a sorted vector, right? Now I'm going to calculate all the prefixes from here. This is also going to take 10 raised power 6 time. Since each search, what I'm going to do, I'm going to search each prefix from the left sub array inside this particular list or vector. So this will take log n time. So the worst case time complexity will be n log n, where n is at most, in the worst case, 10 raised power 6. So what you have to do is, basically at the end, the final conclusion is, calculate all the prefixes from the second array or any one of the arrays. Take the, let's say you calculated the prefixes from the second array. Now take the first array, find all the prefixes and search each prefix in the second array. If the current prefix is present, then my answer is going to be maximum of answer comma current prefix length. This is all you had to do in this particular question. It is just purely brute force. So as you can see, what I've done here is I've created a set of strings. Now you could have also taken a set of integers, that doesn't really matter, but string just felt more convenient here to me. So what I've done is I've just traversed to the second array. Now my current string is going to be basically I, right? This was also not required. You could have just traversed through I. So let's say my current string is I've converted into the current integer into a string, right? Now I will initialize my first string with an empty string. What I'm going to do, I'm going to traverse through all the characters in my current string and I'm going to add it to my current new string, right? So basically I'm trying to calculate all the prefixes of my current string. Now whenever I create a new prefix, I'm just going to insert it into my set. So let me just demonstrate this part again. Let's say my current integer value was 123, right? So it will be converted into string. Now my current string is empty, C is empty. Now 1 will be pushed to my C value, right? And then it will be inserted into my set. Then 2 will be pushed to my C value, then it will be inserted into my set. Similarly, 3 will be pushed into my C value and then it will be pushed into my set. So all of these value 1, 1, 2 and 1, 3 will be present in my set separately. Now what I just have to do is I am going to initialize my answer with 0. I am going to set my array 1. I am going to traverse through my array 1. Again similarly convert all the values, integer values into string, initialize a new string, and in the similar manner I am just calculating all the prefixes. Now I have my current prefix S. I want to search it in my set that I have created. So I am going to use s.findC. If it is not equals to s.n, that means it is present. Then my answer is going to be maximum of answer comma the size of my current string or the prefix converted into integer, right? At the end I can just return my integer answer. This would be the final solution, right? So let me just quickly submit this and show you that this solution is actually working. So you see this is getting accepted and this solution is correct. So now let us move on to the next problem, which is most frequent prime. Now this particular problem says that we have been given a 2D matrix. Now from each cell we have to traverse different directions. What are those directions? We can traverse in 8 different directions, which are east, southeast, south, southwest, west, northwest, north and northeast. Basically all the 8 direction including the diagonals, right? Now we have to select a path and then append digits from these path that is being like the numbers that is being formed by this particular path. So basically let me just take an example and that would be much better. So we are just going to take this particular example. Right, so let me just take it here and now we have this particular sample test case. If we convert it into a matrix, this would be 9, 7, 8 and then we have 4, 6 and 5 and then finally we have 2, 8 and 6. What we have to do is we have to start from each of these positions, starting from here, then this particular cell, this particular cell, this cell, this cell, all of these cells will act as a starting point. Now once we start from any cell, we have to move in one direction. For example, if I decide to move right, I have to move right until I can move. So after 8 I cannot go right because there are no numbers. So 9, 7 and 8, this will be the maximum path that I can form. Similarly 9 and then 6 and then this particular 6 is the maximum path that I can form. Now while traversing, you will see that each number will help me to create a new digit. For example, if I start from 9, I will write 9. Then I move right, I will write 9, 7 and then I move right again, I will write 9, 7 and 8. These 3 numbers will be considered as different numbers. This part is very important. Now among all of these numbers that are being formed, I have 2 conditions, that the number should be greater than 10 and then the number should be prime. If my current number satisfies both of these conditions, I am going to increment the frequency of my current number, right? Once I increment the frequencies of all such numbers possible, I have to figure out what is the number with the maximum frequency. If there are multiple numbers present with the maximum frequency, I have to return the maximum among them, right? So this was my whole question. Now traversing the grid is very simple. You can just create a dx and dy array. Let me just illustrate what these are. So dx and dy array, I'm just going to take it from here. So this is going to be my dx and dy array. Let me just write it first. So here we have it. Now what are these arrays denoting? Let us consider x to be increasing this way and y to be increasing this way, right? So ideally x is this axis and x is this axis and y is this axis. But let us just consider for now, for the sake of this particular problem, that x is increasing downwards with the rows and y increasing rightwards with the columns. Now, if you see, if I have a current value of x and y and I add dx of 0 to x and dy of 0 to y, what will happen? X will get decremented by 1 and y will remain same. So basically, this together 0th position is denoting an upward movement. Similarly, if I add dx of 1 to x and dy of 1 to y, this is denoting downward position because I am incrementing x by 1 and y will remain as it is. Now let us just take this value. So x is decrementing by 1 and y is incrementing by 1. This is upright. So basically this way, I hope you get the point that these 8 values are going to denote 8 different directions. So to calculate one direction, you just have to do x plus dx of I and y plus dy of I, right? This is what you have to do. Now basically you will have to traverse in all of these 8 directions, and like this is the best way to traverse. This is the most clean and good way of traversing in a grid. And once you traverse through all of these values, just have to figure out whichever of them is greater than 10 and whichever of them is a prime. If a number satisfies both of these conditions, I have to increment its frequency by 1 and then basically figure out which one of them has the maximum frequency. Now the second part is very simple, and for the implementation part, greater than 10 is very easy. Traversing through the grid I have already explained. Now coming to this prime part, we are going to use a method called sieve of Eratosthenes. So I'm not going to exactly explain what is a sieve here. You can watch any YouTube video for that. I'm just telling you we are going to use sieve of Eratosthenes, and I'm going to tell you that it will help us to find out whether any number is prime or not. So this particular sieve function, consider it as a black box for now. If you already don't know, you can study sieve after this particular video. So my sieve is going to return me a vector is prime. So what is prime going to denote? The ith position in my is prime vector is going to denote whether my ith number is a prime number or not, right? You can consider this particular sieve as a black box. It will do whatever it wants to do and just return me a vector which will tell whether my ith number is a prime number or not. So once you call this particular function, you can basically find out in constant time whether a number is prime or not. This is why we are using sieve here, and the time complexity of using a sieve is n log n. You can also find it out anywhere on the internet. There are many YouTube videos on sieve of Eratosthenes. I highly recommend you to watch them if you have not already studied sieve of Eratosthenes, right? So basically, I have made the traversal very easy with the help of these dx and dy arrays. You can basically figure out whether a value is greater than 10 or not, and you can easily figure out with the help of sieve whether a number is a prime number or not, right? Now you just have to traverse in all of these 8 directions starting from every point. Again, a brute force question. You just have to traverse the grid. Now let us just have a look at the code, and then it will be much easier. So you can basically see I have first of all a boolean variable computed and a boolean vector is prime. So why are these important? So Leetcode doesn't exactly tell you, but each of your solution is run on multiple test cases, right? So this function will be called by different test cases once, right? So for example, if there are 10 test cases, let's say there are 10 test cases, then your most frequent prime function will be called 10 times. And obviously, I would not want to call my is prime function those 10 times again and again. I would obviously want to call it only once, right? That is why I have a boolean variable, which is a global variable computed. If my pre-computation has not been done, I'm going to call my sieve of Eratosthenes, which is going to return me a vector is prime, right? And I will mark my computed as 1, basically denoting that my pre-computation has been done. I do not need to compute it again. This is what the starting part is. So basically this sieve function will only be called once and not again and again. This is just a simple hack to make sure that our code doesn't run multiple times, right? Now I have initialized my map of frequency. I have taken the dimensions of the grid. I have a valid vector, a valid function. We'll discuss it in a while. Let us see what we have here. We have two different for loops are traversing through each cell of the grid. First loop is going from 0 to less than n. The second loop is going from 0 to less than m. Now I have a simple loop for traversing through all the 8 directions, right? For each direction, I'm going to initialize my current with 0 and x and y with the current I and j. While my x and y are valid, what I'm going to do, I'm going to update the value of my current variable. How I'm going to update it? I'm going to multiply my current variable with 10 and just add matrix of xy to it. So how is it working exactly? Let's say I was at this particular cell, right? I started from 1. Now what will happen, my current value is 0. So I multiply 0 with 10 and then add 1 to it. This will basically become equals to 1. Now let's say I move downwards and come to this particular 9. My current value is 1. I am going to multiply it with 10. Then it becomes 1 into 10, that is 10 itself. And then I'll add 9 to it. So the total number will become 19, denoting the whole number. Then I move downwards and I'll multiply 19 by 10. It will become 190. And then I'll add 1 to it. That will be 191. So basically this will help me to find out the next number in the correct format. Now, if current value is greater than 10 and my current is a prime number, I'm going to increment its frequency and then update by x by dx of d and y by dy of d. So this is how I'm just traversing through all the directions and finding out the next possible values and incrementing their frequencies. At the end, what I can do is, if I will initialize my answer with -1 and my maximum with 0. Now I'm just going to update I'm just going to traverse through my frequency array, and if the frequency of my current element is greater than max, then I'm going to update my max and also update my answer with the current value. So you see, I've taken greater than or equals to. Since the map is always in sorted order of the keys, then when I traverse through this particular array, even if my value is greater, I'm going to update my answer because I want the biggest value, right? So at the end, I can just return my answer and this would be the final solution. So let me just quickly submit this and show you that this particular solution also gets accepted, right? So this was the solution to the third problem. Now coming on to the hard version of the first problem or the last problem for this particular contest. So I can see that around 700 people submitted this particular problem. So this basically says that, we'll come to the question a little bit later, but as you can see, the implementation is a bit long. This actually involves a few concepts. Most of them are just simple implementation code. You can see that this particular thing is purely implementation, doesn't contain any very important logic. You just have to understand the core of this particular problem, and even if you don't really understand how these functions are working, you can consider them as a black box and just focus more on the logic, right? So coming on to the question says that we define a boolean function is prefix and suffix that takes two strings, and it will return true if string 1 is both a prefix and suffix of string 2 and false otherwise, right? So basically, let's say this particular string and this particular string is passed. So the first string is ABA. This particular string is a prefix ABA here as well as a suffix of this particular string. That is why this is going to return true. Now we have to find the number of index pairs I and j such that I is less than j and this particular function returns true. So the very first thing that we need to understand about this particular problem is that no matter what the first string is, let's say it consists of some characters, and let's say the second string also consists of some characters. For any string to satisfy this condition that it is also present in the prefix as well as the suffix, we know one thing, that the prefix of this particular string, the second string, and the suffix of the second string should exactly match, because we are equating it with the same string. That means the prefix and the suffix should be same no matter what the input string 1 is given, right? For the string 2, the prefix and the suffix should be same. This is my very first observation, right? Let me just give you some examples. So let's say I am writing ABA, right? So this particular and this particular prefix and suffix are same. So A can be one of the string 1 that can match this particular pattern. Now let me just remove this. If I consider the first two characters AB, right? The first two characters is AB and the last two characters are BA. There is no string that can be equal to both of them at once. That is what I am trying to say, right? So AB or BA, any of the string 1, no matter what the string 1 is, it can only match with exactly one of the strings. It cannot match with both of them at once because both of them are different strings. So this is not possible at all. Now let us consider ABA and ABA. And now I'm taking a prefix of size 3 and as well as a suffix of size 3. So ABA can be one possibility that can match. Now let me just take, I'm just going to erase this and just going to increase this particular thing further. The next string is going to be AB, the first 4 characters, and BA, the last 4 characters. This is also not going to match anything. But if I do this, ABA, and then ABA, the first 5 characters and the last 5 characters, this is also going to match, and this is going to be my valid string, right? There can be some string which can match with this particular string. That is what I am trying to say. So the very first thing that we observed was independently of the first string, the second string should have some of these matching possibilities, right? Because the suffix and the prefix has to be the same. So our first task should be to find the number of these prefixes and suffixes, or most importantly, what are those prefixes and suffixes for each of these strings that can support this kind of operation. So how can we do? Here I use an algorithm which uses the z function. Now let me just write what z function gives us, and then you will understand it why we are using it, right? So you don't need to understand z function. Let me just show you one thing before discussing it. So what I did during the contest was I just went here and wrote z function CP algorithm. Now you just have to go to this particular website. It's a very good blog for all the things related to competitive programming things, and you just have to copy this particular function, right? I'll tell you what it does, but for the contest you can obviously come to this particular website, and if you see, I have the exact same z function here, right? So I have copied it from this particular website, the main function, right? Once you do this, you need to understand what this z function will help us to do, right? Let me just write the definition first. Z function, if I pass it a string, if I pass z function a string, it will return me a vector equal to the size of the string, where z of I, let's say z is the vector, denotes the number of characters, or denotes the maximum size of the substring starting from current position, which is also present in the prefix of the string, right? So basically z of I is going to return me another vector, or this z function is going to return me a vector of the size of the string, where z of I denotes the maximum size of the substring starting from the current index, and which is also present in my prefix of the past string. So if we discuss this particular vector, let me just draw a proper array for it, right? So we have this particular array. How many characters do we have here? 1 2 3 4 5 6 7 8 9 10 11, right? So I'm just going to create 11 braces: 1 2 3 4 5 6 7 8 9 10 and 11, right? So the character that we have is a b a b a question mark a b a b a. So we are going to focus on the second half only. The first half is not that as important. You will understand in a while why, right? So the maximum length of the string starting from this particular position, which is also present in the prefix of the string, is 5, right? Why? Because a b a b a, this is my current string, right? And it is matching a b a b a. It is matching all the characters. So this is correct. Starting from here, the maximum length of the string that is also present in the prefix of my current string is 0, because the first character here is b and here it is 0, here it is a. Now starting from this position, the maximum length of the string that is also present in the prefix is 3, because we have a, b and a, and here we have a, b and a, right? This is 3 length. Now starting from this position, it is going to be 0, because here it is b, here it is a in the starting. Starting from this last position, the maximum length of the substring which is also present in the prefix of my string is 1, because a is here 1 and a is here as well, right? So this is the final vector that we are interested in, 50301, right? So now if you carefully see, you will observe a very interesting thing, right? Let me erase this. What is this denoting? I've excellently chosen the eraser. So what is this thing denoting? This is denoting a suffix of the string. What is this? This is a suffix of the string. What is this? This is a suffix of the string. What is this? This is also a suffix of the string. What is this one? This is also a suffix of the string. So basically here we were considering all the suffixes, right? Like this. Now what we did was we took the suffix and find out what is the maximum length that is also present in the prefix. So the maximum length in this particular case was 3, which is the whole suffix. So if this is 3 and this is also matching the prefix, that means the suffix and the prefixes are the same, right? So there will be very special conditions. when this value is 3. Why this 3 is important? Because there are 3 characters. That basically means these last 3 characters are also present in the prefix. Here it is 5. That means these last 5 characters are also present in the prefix. Here it is 1. That basically means this last character is also present in the prefix. So these are the conditions where the prefix and the suffixes are the exact same, right? So we are going to use these special positions. Let us consider these as special positions, and again I am telling you that you cannot take any number here. You will only have to consider those positions where this value is equal to the number of characters that are left. Because when this value is equals to the number of characters that are left, that means the whole suffix is equal to the prefix, right? This is what we get through the z function. Now once we get this, now let us consider the original string ABABA. ABABA. So what are the positions that are worth noting? This prefix is worth noting, where we have all the characters, right? And then this prefix is worth noting. Let me just write it. These are the 3 different prefixes in which we are interested, right? The first prefix is only A, the second prefix is ABA, and the third prefix is ABABA, right? Because in these 3 prefixes, the suffix and the prefix are exactly the same. How did I get these 3 positions? The first position that I am interested is in 0, the second position that I am interested is in 2, and the third position that I am interested is in 4. That means in this original string, position 0, position 2, position 4 are denoting the prefixes which are valid for our use case, where the prefix and the suffixes are the same, right? So how can you actually get these indexes 0, 2 and 4? What you can do is, here there are 5 characters remaining, so the prefix should be 5 minus 1, 4. Here there are 3 characters remaining, so the prefix should be 3 minus 2, 3 minus 1, 2. Here there is 1 character remaining, so the prefix should be 1 minus 1, that is 0. So 0, 2 and 4 are these prefixes, or the prefixes ending at this particular position, which are important for our use case, right? Now let's say that basically means A, and then we have ABA, and then we have ABABA. If we find any other string which is equal to this particular string, right, that is going to be our specific use case, and that is going to be beneficial for us. Now once you do this particular thing, you just have to find out how many strings are there which are matching these particular values. That if there is any string which is equals to A, if there is any string which is equals to ABA, if there is any string which is equals to ABABA, and that will be added to our answer, because these are the valid prefixes and the suffixes, right? So this is how you can solve for this particular problem. And then finally you just have to search for these strings, right? You just have to look for these particular string. If any of them is present, then that is going to get added to our answer. So the searching part I actually implemented using try, but while discussing this particular problem again, I realized that try might not be that important, that try is not actually useful. So let me just remove this try. So in order to make the explanation easier, because with try itself the problem is going to be a little bit complex. So I'm just going to remove this as well. Let me wait for a while. And I don't need this here. Match I don't need. I'm going to create a global array. Do I have I used? Yep. So what I'm going to do is I'm going to create a map function, map value. So map string and the frequency. This is basically going to denote the frequency, and I've created it as a global variable. And what I'm going to do here is I don't need this insert part, actually I just need this particular thing. So string current. Let me just explain you first, so that we are on the same page on this one. So let me fix this part as well first. Frequency of words of file, right? So what I've actually done is I again don't need this particular part, so remove this and then remove this as well, right? So I have initialized the value of n with word size, and I have initialized my long answer with 0. I actually got one wrong answer on this particular problem due to taking integers, and I got an overflow. So it means also convert this to long. Right, now what I've done is I'm just traversing through the different strings in reverse order, and I'm just adding this particular value to my answer. So basically I'm counting the frequency of this particular words of I, right? And after I do this, I'm just going to insert this particular word of I. So as I've already explained, each word is going to contribute some specific substrings, right? Either it can, which is going to be the exact prefix and suffix. So we have already discussed in detail here why only this ABA and this particular third string ABA were important from this particular string. This was the original string and we extracted 3 different strings from here. Why are these important? Because these are the valid prefixes and suffix which are exactly the same. So A is present in the prefix as well as the suffix. This particular string is present in the prefix as well as the suffix, and this particular string is present in the prefix as well as the suffix. Right. So what I do this particular thing. And one thing I did not explain, why we did include this particular question mark in between both of the strings. So basically, as I've already discussed, each position is going to denote the maximum length which is also present in the prefix. So if I have this particular question mark, this will act as a delimiter. What should be this question mark, or should it be only question mark or not? You can use any character which you are not expecting in your original input string. This will act as a delimiter, and no value in this particular z function will be greater than this particular size of the string, that is 5 in this particular case, because the prefixes will always match till here. Question mark will never be matched because it was never in your original string, right? So once we calculate this z vector value from the z function, you don't need to know how it works, you just need to know what output it gives, right? Now we initialize my vector of positions, basically denoting the positions which are useful to me, right? So I'm starting with s dot size plus 1 position. So this will be s dot size and this will be s dot size plus 1. That is the first character that I am considering. Now if z of I is equals to t dot size minus I, that means the number of characters that are remaining after this particular position are equals to the count or the number of prefix character that it matches with. Basically, the suffix that is ending from here exactly matches the prefix. This is what this if condition verifies. Then I'm going to count the number of characters that are left and going to subtract 1 from it and push it into my post vector. So that is exactly what I explained here. Here there are 5 characters left. Then I'm going to add 5 minus 1, that is 4 into my answer vector or position vector, then 2 and then 0, right? So basically pose is denoting the positions at which my prefixes are valid. So a prefix ending at position 0 is valid, prefix ending at position 2 is valid, prefix ending at position 4 is valid, right? Now what I can do is I can just add all of these characters into my current string. If my position dot size, that means it has some values, and position dot back is equals to I, then I'm going to increment the frequency of my current string and just going to pop it back from my position vector, right? This is what we are going to do. Now since my frequency map is now going to have all the values required in this particular thing, that means I can directly match it with the frequency vector. So basically this particular string ABABA contributed these 3 different strings. Now I am traversing from right to left. Then whenever I encounter, let's say ABA, I have a ABA, I am going to find how many ABAs were contributed by the strings to the right of it, right? That are already stored in my frequency vector. So I can just add its frequency to my answer and then move on to inserting my current word, and this will keep on going backwards, right? At the end I can just return my answer and this would be the final solution. So let me just test this once whether this is working or not. So we see that the answer is correct here. Let me just also submit this and show you guys that this is the correct solution. So we got a wrong answer. I'm not sure why. Output is 9. So let me just do one thing. Okay, what we did not do was we did not clear the thing f dot clear, right? Since this is a global map f, that is why we must clear it with every test case. I already discussed it in the previous problem when we were discussing about Sieve. Leetcode has multiple test cases, although it doesn't tell you directly. So that is why if you're using a global variable, you must clear it, right? That is why we got a wrong answer here. Let us just try submitting it once more. Okay, so we got the memory limit exceeded. Okay, so I believe that a try is the only way. You must go ahead with this particular problem. because obviously the try will use less space. So I'm just going to go to my submissions, and this was my accepted submission. So I'm just going to copy it. I'm also going to explain why try is important here. I thought that we might go ahead without using try, but it is not possible, certainly not possible in this particular case. So now let us discuss what are the extra things that were added because of try and why we could not solve this problem without try. So let me just remove this as well. So you see, like these videos are nice for myself as well, because while discussing the question I thought that this might be possible without using try, but now I have realized that you can possibly not do it. So let me submit this and show you first that this solution is working. So you see this is getting accepted. Now let us discuss why try is not working. So you see we are creating multiple such strings, right? And let's say we have this particular string AA. So every suffix is getting matched with every prefix. So that means this particular string will contribute n substrings, right, to our answer. And let's say that there are total number of n words, each word is contributing n substrings, then it is an n square approach in terms of space. That is why we were getting memory limit exceeded, right? So if I show you here that the words length is up to 5 into 10 power 5, that the sum of words length is 5 into 10 power 5. So basically 5 into 10 power 5 whole square is going to be a overall space complexity, and this is not very optimal. We do not want to do this. So the only difference that I am going to make is by using try. Rest the solution is the same. Let me just explain you how we are using try. I'm not going to explain how try works in a general case, but I'm going to explain how am I trying to use it here, right? So I created a class try node, and it is going to point a next character, which is an unordered map. The first part is the character and the second part is a try node, right? So this is going to be the next pointer. Now I also have a count variable. So this count basically will denote the number of strings that are ending at this particular position. So if you have never studied try, you're not going to understand this explanation. This explanation is only for those people who already know how to use a try or are aware about some basic definitions about a try. So let's say this was my string A, B, A, B, A, right? So I want to store A, ABA and ABABA inside my try, right? So it will be stored like this, and then let's say B is here, then let's say next is A, and then we have B, and then we have A. So this whole thing will be stored in my try. But the only thing that I was important to me was this particular A, this particular ABA and this particular ABABA, right? That means this one and this one and this one, right? So I need some way to make sure that these are the only substrings that I am interested in, right? I'm not interested in AB. It is still present in my try, but I need to make sure that this is not the string that I'm looking for, right? That is why I need a count variable, or you can also say it as an end variable denoting how many strings are ending at this particular position, right? Whenever I create a new node, this count should be equals to 0, right? Now what I'm going to do, let's talk about this particular insert function first. So what I'm going to do in my insert function, my try node is going to initialize my current node with the root node. So I'm passing this root node from here, right? Now I've initialized my I with 0 and n with s dot size. So basically I do not need this I variable, right? This z function is same, position vector is same, this part is the same that we discussed. Now I'm traversing through all the different characters. Now if the node next already has this particular character, that means node next dot find s of I is not equals to node next end. That means this is already present. I'm going to set my node as node next s of I. If it is not present, I'm going to create a new node, set node next s of I as new node and update my node as new node. Now comes the important part. Here in the previous implementation, I was adding or incrementing the frequency of my current string by 1. Similarly, if pose.size and I is equals to pose.back, that means this is an important index, I am going to increment the count of my current node and just pop it back from my positions vector, right? So here at the same position, we were incrementing the frequency of the string. If memory was not an issue, then here we were incrementing the frequency, that would be the same, and here I'm incrementing the value of node count, right? Now similarly, there I was just directly using f of the frequency of words of I. Now I have to match the current string in the try. How do I actually match it? I'm going to start from the root node. If the next variable is possible or the next character is possible, I'm just going to move on to it. If it is not possible, I'm just going to return 0 because I was not able to find my current string. Now at the end, if the whole string is matched, I also need to make sure that this particular value is returned. I cannot just directly return any value. I have to return node.count. This basically is denoting how many strings are giving an exact match with this particular input string. Right, this is what is going to be denoted by node count. And at the end, I can just return my answer. You see, most of the solution is the same. Just the try thing is very included in this now. And you can clearly see that most of it is just basically implementation based thing, right? The core logic was this one, how to find out these valid strings, right? This was the core logic. Now, if space was not an issue, we could have directly used a map. But since here space was an issue, we had to use an optimal data structure to store and find the patterns like a try. Right, so this is how you can clearly solve this problem. I have already submitted and shown you that this particular is getting accepted. So this was all about this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. Don't forget to share thoughts in the comments because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you and you'll be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.